Let's take a look at solving radical equations. There are 4 simple steps to solving radical equations. The first thing you need to do is isolate the radical term. So if you look at our first example here, we have the square root of 2t minus 1. That is the term we are going to isolate, which means 2t minus 1 will be on one side of the equation, and we'll add the 3 to the other side of the equation. You want to isolate the radical term, and you can write up here on one side of the equation. Now, step 2 says to raise both sides to this should say power of the index. So my index right here is a 2 since it is a square root. So basically, if we square both sides, the square and the square root will cancel, and I'll be left with 2t minus 1 equals 9. From there, you're just going to solve it algebraically, like it says in step 3. Solve for x, or in this case, t, and I do get t equals 5. Step 4 says check for extraneous roots. This came up last chapter when we were looking for solutions to rational equations where we had some where the denominator equaled 0. We called those extraneous roots. Same thing we are going to look for here. We're going to plug in 5 and check to see that it works in the original equation. So 2 times 5 would give me 10, minus 1 would give me 9. So this would be the square root of 9 minus 3. Does that equal 0? Well, square root of 9 is 3. 3 minus 3 does equal 0. So our solution here, 5, we solved for and checked. We are done. For the second example here, we have the radical already isolated. So once you have the radical isolated, you're going to raise each side to the power of the index. So again, we have a square root, so we're going to raise each side to the second power. Square cancels a square root, and you're left with your 7x minus 12. On the right-hand side, x squared would be x squared. Now, you know how to solve equations that look like this. You need to get the equation set equal to 0, need to add or subtract everything to one side, and then we're going to factor. So two numbers that multiply to positive 12, add to negative 7 would be 4 and 3, both of them negative. So we set up our factors, x minus 4, x minus 3, and we get our two possible solutions, 4 and 3. You then need to check. So we would look at the square root of 7 times 4 minus 12. Does that come out as 4? Well, 7 times 4 is 28, minus 12 is 16. The square root of 16 is 4, so 4 can be included as one of our solutions. Now let's check 3. 7 times 3 is 21. 21 minus 12 is 9, and the square root of 9 is 3. That one also checks. So we can include both solutions as part of our answer. Now, as you might see, this one got a little more difficult than the last one, and number 3 is going to be even more difficult. We are going to isolate our radical term by adding the other terms to the other side. We then are going to raise each side to the power of the index. Now you need to be careful. If this radical term does have a coefficient, you do need to square it and the square root. So we're going to take 3 squared and get 9. The square root of x plus 1 squared is x plus 1. On the right-hand side, we are squaring a binomial. You need to write it out twice and FOIL. From there, it is just algebra steps. So take a moment to complete those. You do get -1 and 8 as your answers. Again, be sure to check them. Now, the last cases you're going to see are two radicals in the same equation and a cubic. Let's start with the cubic. This one's meant to be easy. We still isolate the radical term even though it's a cubic here, so we're going to subtract the 5. Then we're going to raise each side to a power of the index. In this case, we're going to be cubing it, and x in this case is going to come out to -8. Then all you have to do is check it. The cube root of -8 plus 5, does that equal 3? The cube root of -8 is -2. -2 plus 5, does that equal 3? In fact, it does. So our solution here would be, -8. Now, for number 4, when you have two radicals, it's impossible to isolate a single radical. So instead, what you're going to want to do is put one radical on each side. So I'm going to move the square root of c plus 6 to the other side. I'm going to put one radical on each side. Now, you do still raise each side to the power of the index, but here's what's going to happen. The squared will cancel this square root since it's just a single term on this left-hand side. However, on the right-hand side, we are squaring a binomial. Just like always, you are going to have to write this out twice and FOIL. As you start to FOIL here, you might notice that your square root is going to stay. A good rule of thumb, or something to think about, is if you start with two radical terms, you're going to end up raising your equation to a power twice. So make sure you do get what I am getting for the FOILing and sum of the terms on the right-hand side. Again, we notice we still have a radical, so you do want to isolate that again, meaning subtract the c, subtract the 7, and isolate your radical. Once you have your radical isolated, you then can again square both sides. So I'm going to raise each side to the power of 2, which in this case will take away my radical. Don't forget to square what's on the outside of your radical. And again, write it out twice and FOIL for that left-hand side. From there, it's just algebra, so I would like you to take it down from there, set it equal to 0, and solve. Make sure that you are going back to check these two solutions of 3 and 19. You should find that 3 does not work, and your only solution here is 19.